Hello again, Year 7. So this is your first video of the week, and this is lesson number 30. So we're looking at chapter 12G, which is all to do with volume. Now the first thing to make sure we're happy with is what this word volume actually means. So volume is just the amount of 3D space a shape takes up. It's very similar to area, but that works for 2D shapes. Volume works for 3D shapes. Okay, so it's the amount of space in 3 dimensions that the shape takes up. Now, there's a couple of different ways that we can do or work out the volume. Now, in all the ones that I'm going to do here, they're all going to have straight sides. There's not going to be any circular shapes or anything like that. Now, one way that we can work out the volume is just by counting squares, counting cubes. So here we're told in the example, now I've not included it here, but that one cube is made, or its volume is a centimetre cube. So that's 1 centimetre cube. Well, if we look carefully at this first one here, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 cubes. So therefore the volume is 9 centimetres cubed. Now this unit here is really important, because if that wasn't a 3, if that wasn't centimetres cubed or cubic centimetres, then it would be marked wrong. Okay. Here we've got 1, 2, 3, 4, 5. Now remember what I said last week when we were looking at isometric drawings. If there wasn't a block underneath that cube there, it would fall down. So that we know there has to be one. So that tells us we know that our volume, or the amount of little cubes that there are, is 6. So the volume is 6 centimetres cubed. And finally on this one, we've got 1, 2, 3, 4. Now there has to be one at the back. 5, 6, 7, 8. There has to be one at the back, because otherwise the one on top that I forgot to count, so 9, that would just fall down. So we know that that volume has to be 9 centimetres cubed. And I'll just explain that one more time. So this first row here must basically look like that. Sorry, that's a really rubbish drawing. The one on top must look like that. And then the top one is just a cube. So that means there must be 9 cubes that make that shape up. Okay. This one here is a cuboid. It has a special name. Now, the way we can think about shapes that are like this is the amount of layers that it has. Okay. Now in this one here we've got the top layer, the middle layer and the bottom layer. You should be able to spot that the top layer, the middle layer and the bottom layer are actually all the same. So that means we could work out, let's just look at the top layer here. So what I mean by that is just that bit there. I'm going to ignore the rest. I'm going to imagine that the rest isn't there. Now the volume of that top layer is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And we know that there are 3 layers that are exactly the same. So how do we write that? Is going to be, the volume is going to be 20 times by 3. So that's the volume of 1 layer, and that's the number of layers. Okay, which gives me 60. Now, the measurements are all in centimetres, so therefore my volume must be in centimetres, but it's a volume, so it must be centimetres cubed. Now, we can look a little bit more closely at the numbers here. Now this 20, if we think about it, we went along by 5 and then along by 4. Along by 5, then along by 4. And then I multiplied it by 3. So let's say that that is my length, that is the width, and that is the height of the shape. The volume of a cuboid, this also works for a cube as well. The only difference for a cube is all 3 of these dimensions or lengths will be the same. So the volume of a cube or a cuboid is length times width times height. Mathematicians are a little bit lazy, so we like to shorten things. The volume is L times W times H. But this formula only works for cubes and cuboids. Okay. So hopefully that's helped, and you can now have a go at chapter 12G, which looks like this. And good luck.